Let's keep moving on with 2025, question 3 from the free responses. Here we go. A box is connected to one end of a rigid rod. Both the box and the rod have negligible mass. The other end of the rod is connected to a pivot. Boom. There's a box. There's a block in the box. The box is open on one side. Great. The center mass of the system is displaced by a vertical distance h. Cool. Swings downward. There's negligible friction. That's nice. When the system is at the lowest point, the rock collides with a rigid stopper. The block comes to rest and the block is launched horizontally. Okay, that way. And the block moves across a horizontal surface. Okay, so it's not even a projectile. And towards a motion sensor that measures the speed of the block. All frictional forces are negligible. How lovely. Students are asked to experimentally determine the acceleration due to gravity, g, using only a linear graph. So we remember that this question 3 is always going to be some sort of experiment and you're going to have to linearize something. So that's just what we're preparing ourselves for here. So we're trying to determine g. The students are permitted to use measurements from only a meter stick and the motion sensor. Describe an experimental procedure using the described setup to collect data. Allow them to determine the value of g using a linear graph. So this one's going to be pretty easy here because the setup is going to be that the height right here is going to translate into velocity. So just remembering mgh is 1/2 mv squared. So the m's go away and we always get v is square root of 2gh. So we know if we measure the velocity and the height, then we can get g in there somewhere. Actually, it's almost better to make it v squared equals 2gh, and then we don't have to take a square root with the slope. So what I would say for part A is measure h and v across table, and then take multiple measurements. And I always say you're going to write neater than me because you got some time. Just slow down. You're good. Got some time for this. Got 25 minutes each question, so you're fine. Measure h and v across the table and take multiple measurements. Maybe expand on that with another sentence or something. Now describe how the data collected in part A can be graphed and how that graph would be analyzed to determine the value of g. So for this one, what we're going to say is we're going to say just what we did up here. I would note that v squared is 2gh. So if we graph v on the y-axis, maybe I would do g, oops, let's not do it there. Maybe I would write it like this. G times 2h. Good. And that way g is my slope and 2h is my x-axis for my y equals mx. And then I would just say graph v squared versus 2h, and then the slope equals g. So that's pretty easy to do. Okay, going over to part C. Okay, so they're not actually having you graph that one. They're going to give you something else to graph. The experiment is repeated, but the horizontal surface on which the block sides is replaced with a new rough surface. It has a coefficient of friction of mu, so then it's going to slide to a stop. The block box system is pulled aside. Center of mass is displaced, so it's pulled up the same distance h. It looks like all we're doing is adding in friction. For each vertical distance, students measure the position in which the block comes to rest. The students' measurements of h, x max are shown in table 1. Indicate two quantities, either measured quantities or additional calculated quantities can be graphed. Produce a straight line that can find mu. So basically we're trying to find mu. And this is once again another conservation of energy idea here, but they're trying to get you to remember about work. So this one is we're starting out with our mgh from our potential energy from this thing, and then we're skipping over the kinetic energy and we're just going straight to force times distance. And that's going to be the work that friction does in slowing this down. So friction's doing some work and slowing it down. It's nice that it's a constant force because then we don't have to do an integral. If it wasn't a constant force, we would do like f dx. So I could see a scenario where they would say the friction on the surface is given by F equals something something, right? F of X equals something something something. They give you a function that you'd have to integrate. But this one's actually pretty easy. Actually, that would be really tricky because if you're trying to graph things, then that's going to make it a really hard thing to do, to incorporate a linear graph with that. So what do we do with this? The force over here is going to be mu times the normal force. And of course, that's going to be mu mg. So this is all going to come together as mgh equals mu mg. The g and the m go away. Oh, we forgot the x. It's like something's weird here. Mu mgx. So that's it. So we can get h equals mu times x. Well, that's pretty easy. And then we just do y equals mx over here and indicate two quantities down here. So it looks like my vertical axis, I'm going to plot h, and my horizontal axis, I'm going to plot x max. Boy, they made it a really easy one over here. H and x max. That's it. It almost seems too easy. I would like, if I was doing this on the AP test, I would be a little bit nervous because I'm like, well, that is way too easy. It's got to be a squared or something in there, but no, that's it. And then of course they have on the grid provided, so you're just gonna make some careful choices for what you're doing from the bottom here to the top here and the bottom here to the top here. Clearly label the axes. Don't forget to label the axes. So this is going to be h, this is going to be x max. You're going to plot some points. You're going to try to take up as much of this grid as you can. Boom, 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 boom. You're going to use your pencil or another straight edge to make a line. And then once again, you're going to find the slope right here. You're going to calculate the experimental value for mu. And when you're finding the slope, draw a circle around here for that's 1 point, and there's another point I'm going to pick to do my rise over run. And then you can do your rise over run, and then you're going to get that the slope is going to equal mu. Okay, that's pretty easy for a question right there. Almost too easy. But like I said, if this was a question on the AP test, and it was last year's question, I would be nervous that it was too easy. But sometimes you catch a break.